Hi guys, it's Walter Prowse here again. Today's lesson is going to be on non-right angled trigonometry. So beforehand we we're dealing with all right angled triangles, and now we're dealing with non-right angled trigonometry. So the triangles are now no longer going to be right angled. Okay, so the first thing you need to know about non-right angled trigonometry is firstly the sine rule. Okay, so what is the sine rule? It's just pretty much a formula that's used for finding the lengths and angles of non-right angled triangles. And what we use here is a formula. So here we've got this formula and we've got this formula. It's exactly the same thing, both of these formulas, just the flipped version of each other. So we use this top one here when we're finding a side length, and we use this one here when we're finding an angle. So you've got to make sure you use the right formula depending on what the questions are asking. The next thing you need to be aware of is what a pair is. So the term pair in this context is a particular angle, and we call that particular angle capital A, and the pair is a particular angle and its opposite side length, and we call the side a little a. So a pair is a capital A and a little a. There's our pair. So they're the same letter pretty much. So yeah, don't forget that, a really important concept, that pair. Okay, so for example, let's consider this triangle down here. So here we've got an angle and its opposite side. So this is our pair. We've also got another pair over here, this angle and its opposite side. So that's also a pair. You could even, if you wanted to, you could call this one C and tiny c, and that would be a pair as well. Okay, so moving on. Some rules to remember. When you're dealing with these non-right angled triangles, to be able to use this sine rule, you need 3 pieces of information about your triangle to be able to determine an unknown side or an unknown angle. It's really important to remember 3 pieces of information. So an example is, and also note, to use the sine rule, you need to be given 2 pairs in your question. And if you're not, then you have to try and figure out how you can kind of fix up that issue. So once you know 2 pairs, you're allowed to go straight to the formula. So an example is this. So hopefully this will make this seem a lot more sense. Make a lot more sense. So first up, I want you to see that I've given you 3 pieces of information. So that is enough to be able to use the sine rule. But you also need these 2 pairs. And so the 2 pairs that we got is this side and its opposite angle. That's one pair. And another pair is this x and its opposite angle. So we have our 2 pairs going on there. So that I've given you all the information required to go straight to the formula. So let's give it a shot. So see here, we see our pairs as I've highlighted. And literally, we start with the formula. We're finding an unknown side. So I use this one here, remember, where the little a and little b are on top when we're finding a side length. So you start with the formula. And in this formula, you have little a in capital A, little b in capital B. That's where your pairs go. So x and 17 go on top of each other like that. And the sine has to come down, obviously. And the 18 and this 47 degrees and 35 minutes, that goes on top of each other like that. So that's how you put into the formula. Next, looking at this formula, you have to think to yourself, how do we get our x by itself? So x is with sine 17. That's dividing, so we have to multiply both sides by sine 17. So you have to remember that those 2 will cancel out, leaving you with just your x. And when we do this fraction multiplied by this, you got to think to yourself, this is just going to times the top number, because this is like 17, sine 17 over 1. So literally it's going to be top times top, and then the bottom times is by a 1, which is secretly down the bottom of this sine 17. Okay, so then you end up with this. So it's like that sine 17 just slots up the top. So when you get this, x is now by itself, and you shove all this into a calculator, and you get 7.1 meters. So that's our value of x, done. So that's the first typical sort of situation when you're dealing with finding a side length. But what about if you're trying to find an angle? So very similar. We still need our 3 pieces of information, and we still need our pairs. So there's one pair, and our other pair is right here. So we've still got two pairs, so we can use the sine rule. But just quickly, I want you to note, look at this unknown angle. That angle is going to be measured in degrees and minutes, etc. But it's definitely obtuse. It's a really big angle. It's bigger than a right angle. So we know that it has to be between 90 and 180. So it's a really important idea. You've got to keep that in the back of your mind. Okay, so let's give it a try. So our two pairs are there as shown. We use this formula, so the flipped version, because we're finding an angle. And now we substitute. So our theta and our 24.5, that's the first pair that goes in there. And the other pair is our 17.5 and our 15. So there's our next pair there. So they pretty much just go straight in following that formula. And now we have to think to ourselves, how do we get this theta by itself? So we have to get rid of the 24.5 by multiplying both sides by 24.5. That means that and that will cancel, leaving us over with just sine theta. And remember, the 24.5 goes up the top, it doesn't multiply the bottom. And now we think to ourselves, we still want to get theta by itself. We have to somehow get rid of the sine. The opposite of sine is sine minus 1. So we do that to both sides. Sorry, that won't cancel. Okay, so that will get our theta by itself. And the way to write this is you need to have this sine minus 1 theta. That needs to go at the start. And then all this stuff just goes straight into those brackets in your calculator. So when you do that, you end up getting 21.2 degrees for your theta. But that is definitely an acute angle. That's a very small sort of angle. It's not obtuse. So there's a real problem with this answer. It can't be right. So when you're in this sort of situation, you have to remember, I have to actually change it up. The way to get the correct obtuse angle from this is to subtract this answer away from 180 degrees. So you take 180 degrees, take away your answer, so 21.2 degrees, and then you get your final answer of 158.8 degrees. So that is the obtuse angle that you want. So hopefully this is enough to help you out with some of the questions you're going to have to be dealing with. Good luck with it all. Bye.